the basic data analysis. Sir, hello.
Hello, sir.
Sir, am I audible?
Yeah, sir. Audible, sir.
These are the contents, today covered contents. Okay, next. Data. What is the data? Data is the information, maybe in number format or in sentence format, under particular concept of investigation, under particular concept of investigation. If you are asking any person what is your age, they said in terms of numbers, age in 37 or 48, like that, in terms of numbers. If you are asking any question like what is your favorite food, they are mentioned some in some terms of sentences. That is also data. Okay, this type of data we are using. Okay, sometimes if you are generated from the system, in the system, it is in the binary code. Okay, that is also data. Here we are discussing about the types of data. Basically, SPSS software need some basic rules and some data types needs, okay, to enter the data. For that, I am explaining this. Okay, data types based on measurement scale. We have two types of data types. Based on measurement scale, we have two types of data types. One is quantitative data type and another one is qualitative data type. In quantitative data type, scale measurement, ratio scale measurement, interval scale measurement. Qualitative, normal and ordinal scales. Okay, coming to the scale measurement, if you are measure anything with physical measure, like distance, what is the length, distance, these are all measured in terms of centimeters or kilometers. Okay, another weight, kgs, grams, kgs, in terms of grams, gold in terms of grams. Like that, we are using physical measure, exact physical measures. With the if you are using exact physical measures, that type of data comes under scale measurement. Okay, if you are measured with respect to another, what is the speed of a car, that is in terms of per hours, 60 kilometers per hours, 40 kilometer per hour. Okay, here uh, uh, we are measure the data in with respect to time, like that time, like that way. These type of measure, all type of measurements are under comes to the ratio type. Interval. Okay, next, interval scale measurement. In this interval scale measurement, what is expected salary, that is in terms of 35 to 45, or 50 to 60. This is the interval scale. If you are mention in between the two numbers, in interval, that is the interval measurement. Okay, coming to the qualitative. In qualitative measurement scales, nominal scale, if you are measure without any proper physical measurement, by visual or by randomly give answer by visual. If you are by observing, if you are giving the answer by observing it, what is your favorite color, what is the time now, what is the sky color now, what is the sky color now, it is blue. You don't know, you cannot apply any measure for measuring that color blue. Okay, what is your gender, you don't have any scale. What is your skin color, you don't have any scale. What is your favorite food, you don't have any scale. But we can say quick answer, some assumptions, based on some assumptions, based on some measurements. Here we cannot apply any proper measuring scales. Based on some assumptions, if you are giving any answer, that under that type of answers comes under the nominal scale. Okay, ordinal scale, these are the same type of nominal scales, but it in the under the order, because what is your qualification, Qualification gives, if you are illiterate, in this qualification scale, illiterate, literate, SSC, your undergraduation, graduation, next higher studies. These are the order scales. Like that, like the type of scales are under ordinal scales. Okay, these are the measurement scales. These are the measurement scales. Come to the uh, representation scales. Come to the representation. Systems are read only either numerical values or character values. Okay, based on that representations, we have two types. One is numerical data, another one is character data. In this numerical data, we have discrete values and continuous values. Under character data and string data. Okay, coming to the numerical data. In numerical data, we have discrete data. If you are count anyone, if you count anything, that terms come. Sorry, any doubt?
No, sir.
Okay. If you can, if you can if you can count anything, if that comes under the discrete type of data. If you not count anything, that comes under the continuous data. Suppose for discrete example, number of persons in this class, uh, 37 or 47 or 57, that will be the count. You can count only. What is the time now? You can't exactly, can't say exactly time now. That comes under the continuous data. Number of persons in a class comes under the discrete type of data. If you are count exactly with the numerical values, that comes under the discrete data. If you not count exactly, if it takes some values, take values, what is the weight of a chalk piece? What is the weight of a chalk piece? That takes some 46 grams something. Okay, 46.28 grams. If you measure, if you are mentioned in real values means with the decimal values, that comes under the continuous data. If you are measured only real numbers, counting values, that comes the discrete values. Okay, character, if you are comes under the character data. Coming to the character data. In character data, if you are mentioned with only single letter, that is the character data. If you are mentioned with combination of characters, that comes under the continuous data, string data. Okay, these are the types of data based on measurements and based on representation. Okay, coming to the SPSS. Okay, SPSS is a, is a software, statistical software. Okay, statistical package. SPSS is a statistical package for solutions and suggestions. It's full form. Okay, it likes this way. It looks like spreadsheet. Okay, in this spreadsheet we have same menu bar. This is the menu bar. In this menu bar, file. In this file we have open, new, open, import data, and other. In this edit, undos and the other views, data types, transmissions, analyze, graphs, utilities, extensions, windows, help. In this we are using mainly transforms and analyzes and graphs. Okay, right. See, in this window we have two sheets. One is data view and another is variable view. In this data view we are enter the data. In this variable view we are here we are declare the nature of the variable. Okay, we here declare the nature of the variable. Suppose here name of the variable, first column text in this variable view. Here we are declare the variable nature, first name. In this name column, first we are enter the name of a respondent or age. Here age is in numeric form. If you are click in this point, we have it opens the another window. Okay, in this window, data variable type. Here we are define the variable types. Here see, numeric, age is numeric, comma type, dot type, scientific notations, data, date, dollar, custom currency, string, restricted numbers. Okay, like this way we have defined the variable type, and also defines the length of the variable, width and size with the decimals or not. Okay, is here I am taking uh, 5 characters, 5 characters width, 5 characters width, and 0 decimals for age. Okay, click OK. It's a numeric, age numeric. Next, width decimals. Next, label. In this label column, we define the question, age of a person. Okay, here we can write your questions directly. Here it is the values. In this values column, we define the options. Okay, it is okay, missing values and other. This is the role. It's input variable. Okay, this is the measure type. See, under measure type column, we can select the scale type. This is the scale type. Numeric age is the scale type. Okay. Coming to the data, see, this is the one of the questionnaire. Okay, a survey on women empowerment. In this questionnaire, name of a respondent, age, family income, religion, number of children's, working woman or yes or no, education qualification, age, age at marriage, age of first children birth. Like this, these are the questionnaire in this survey. Okay, first of all, see, first thing is name of a representative. Okay, name of respondent. See, simply I'm paste the values exactly here, questionnaire, but here I'm define name. This is name is string value. So I'm selecting the variable type as string. Okay, string. It is nominal. Name is the nominal. What is your name? Without measure, without any qualification, without any restrictions, we are give the answer as a name. Okay, so that is the nominal. Okay, next, age. Age is the scale. We are measured with the years. Okay, so we are taking it as the age scale. Next question. Come to the next question. Family income. Family income. See, family income. This is a numeric value. So automatically it takes the numeric value. So here it is also scale value. Okay. Next, number of children. Children. Number of children. Here number of children, we are giving the count only 1, 2, 3, or 4, 5. Okay, like that way it is also numeric. Take it as a scale. Next, coming to the questions. Number of children. Religion, if you are mentioned it is a Hindu, Christian, or Muslim, it is in the form of string. Okay, okay. Religion, see, Here we have some options. Hindu. Okay, here we are define the values. One for Hindu, two for Muslim, three for other, three for other. Like that way we can define. Like that way we can define. Okay, next, number of children. Uh, are you working woman or not? This question I directly copied. Are you working woman or not? See here, simply I am define variable name as working. Here we have two options. One is yes, another one is no. Okay, this way we are declare the entire data. This way we are declare the defines the variables. This way we are defines the variables from the data. From the data sheets we can enter the data. Okay, age 37, name, next income, children, religion. See, if you are click here, it will takes working. Like that way we are enter the data. Okay, I will show some data sheets. See, suppose some enter some data. This is the main data we are entered into the data. Open, I will open the data. This is the data: name, age, income, religion, children, working or not, qualification, married, support. Okay, see here I am defined like that way. Name of respondent, name of respondent, age of respondent, family, income, religion. See, religion: one for Hindu, two for Muslim, three for Christian, four for other. Okay, next, number of children is the numeric. Next, are you working woman? Yes or no? One for yes, two for no. Next, education qualification: one for uneducated, two up to 10th, three intermediate, four graduate, five postgraduate, six and above. Okay, next, married age. Married age, here married age divided into groups: one for 12 to 18, two for 18 to 22, three for 20 to 25, four for 25 to 28, five for 28 and above, six not married. Okay, uh, income support in family. Do you have any income support in family? Some extent, to target extent, no at all. I am the only person. These are the options. These are the options. Like this way, I'm define the questionnaire in SPSS. Okay. From the data sheets, I'm enter the entire data. I like this way. Okay. With this data, first of all, we draw frequency tabs. First of all, we draw the frequency tabs. See, frequency tabs. For frequency tabs, go to analyze and select frequencies from descriptive statistics. Okay, here names are different. Okay, names, leave the names and select remaining all one by one. Family, income, religion. If you are select at a time also, can select at a time also. Okay, see here statistics. In the statistics, mean, median, mode, sum, percentiles, and standard deviation, variance, range, skewness, kurtosis, you can calculate here. Click OK. See different ages. In this we have 23 age persons. In this data we have 23 age persons, 3 members, and like other. Okay, next, family income. This is the family income frequency table. Religion, Hindu. From Hindu religion we have 21 members, Muslim 5 members, Christian 6, and other 3 members. Okay, this is the frequency table. Percentage and cumulative percentages. Number of childrens. In this data we have 10 members have 3 childrens. Okay, are you working women? This data is from working women, so everyone says yes. Okay, education qualifications. This is the education qualification. 13 members have graduations, undergraduate students. Okay, see here what is the age at marriage. 16 members get marriage between 18 to 22. Okay, followed by a 20 to 25 age group. This is the frequency, simple information. With this data we can draw. This is the output window. See here, this is the output window. If you are draw any conclusions, the all are comes under output window only. This is the data window. This is the output window. See, we have another window. This is the output window. In this output window, every calculations are presented here. Okay, next, simply these are the methods to enter the data. Next, coming to the statistical analysis. Okay, first thing, find correlation coefficient between the heights of fathers and sons from the following data, and also sample correlation is significant or not. Test sample correlation is significant or not. This is our problem. See, for this problem we know the correlation coefficient formula. See, this is the Carl Pearson correlation coefficient formula. Here they are asking also test the significance of correlation. Okay, for the test the significance of correlation, we have t-test formula. This is the significant correlation coefficient formula. I will explain later after the completion of the calculations. Just open. See, here I am define father, son, father's height, son height, variable names father, son, and father son, father, son, variable names father, son, labels father height, son's height. Next, these are the numerical type of data. Next, I'm enter the data in two columns. First column, father side. In second column, son side. Simply, to calculate correlation, go to analyze, and select bivariate correlation from correlation. Select bivariate correlation from correlation. See, simple, analyze, correlate, correlate. In this bivariate correlation, pass these two datas to the calculated field. See here options: means, standard deviations. If you know the means and standard deviations, you can calculate this. Otherwise, simply select here. Defaultly, it takes the Pearson correlation. We have other measures: Candles correlation and Spearman correlation. This is Spearman rank correlation we used for ranked values. Here we are directly calculate the correlation. Two-tailed test significance, two-tailed. In this hello, see, this is the output for correlation coefficient. In this output table, we are consider only the first row. Okay, first row, Pearson correlation coefficient. This is the value. See, this is the value. 0.8692 is the correlation value. Okay. Next thing, significance. This is the significant test. Also, it's calculate the significance. SPSS calculate the significance also. If the significance is less than 0.05, if the significant value is less than 0.05, that means in previous classes, all of you know the significant values, how to check the significances. Okay, how to check the significant values. See, this is the correlation value. R equal to 0.070, 0.80. This is the correlation value. Okay. Next, significant value. Simply, that is significant value. Significant value is the p value. In this software, we get p value as significant value, that is 0.011. If this value is less than 0.05, we accept the we reject the null hypothesis. Okay, if it is greater than 0.05, we accept the null hypothesis, and we conclude that if with this result, we have correlation value 0.87. That gives the strong positive correlation. That indicates the strong positive correlation. Okay. Next, we says that significant. This is the significant. There is a statistically significant relation. There is no statistical. There is a statistical significance. Okay, with this value we are explain statistically significant. This is the statistically significant. Like that way we define the conclusions. We will give the conclusions. Okay. Next thing, if you are want to calculate rank correlation, that is also same process. that will gives the same result. That will gives the same result. See, analyze correlation, bivariate, select Spearman rank correlation, select Spearman rank correlation. See, the same we have get only same answers. Okay, here also significant. This is also significant. Okay, next level. Next, in this next problem, we have fit a linear regression to the following data. Test the validity of estimation. Okay, height and weight. Height in meters, height in meters, weight in pounds. Okay, weight in pounds. This is the data. We have 12 members, height and weight. Find whether there is any relation between height and weight. Test the find the relation between height and weight. Mathematical relation between height and weight. Now I enter the data in spaces. Okay. Now open the correlation data. See, here I am define height, weight. These two are the numerical values. Okay, these two are the numerical values, and enter the data under height column, weight column. Now I define. Now I derive the regression model. Go to analyze and select linear regression from regression. See, in this analyze, in the click on the regression. In this regression, we have another window. In this another window, select the linear regression. Okay, select the linear regression. Here, we define a dependent variable and independent variable. Here, weight is the dependent. Weight is the dependent on height. Weight is the dependent on height. So weight is the dependent variable. Weight is the dependent variable. Height is the independent variable. Okay. See, if you are select in the statistics, estimate values, R square values, here we can test the different type of tests, residual tests, error tests. Okay, you can plot X, Y graphs also. Simply click OK. If you click OK, you can get the model. This is the result. This is a regression model. In this regression model, we are using the height is the independent variable. Okay, weight is a dependent variable. See, this is the R square value, adjusted R square value. R square value is 0.3. R square value. This is the R square, R value, R square value. R square value is 1. R square value is 1.39. Adjusted R square value is 0.52. If R square value is tends to nearer to 1. If R square value is nearer to 1, or R square value equals to 1, that is the best model. R square, first thing, R square lies between 0 to 1. If R square is nearer to 1, that is not a good model. That is not a good model. If R square is nearer to 1, that is the good model. If it is nearer to 0, it is not a good model. If it is nearer to 1, it is a good model. But here we have getting, unfortunately, nearer to 0. Nearer to 0. That is nearer to 0, not a best model. But in this data, we are getting this value. Okay, this is the validity test for a fitted regression model. See here, these are the coefficients. Okay, where is this the coefficient? See, these are the coefficients: intercept value and coefficient of height. Okay, y equal to mx plus c. In this, y is weight, m is coefficient of height, plus c intercept value. Okay, for finding weight, we have this m or beta, this m or beta naught. Okay, is 18 18.735 into height plus constant 106 106.59. This is the uh, this is the estimated line. Okay, this is the estimated line, and here we are testing the significance of estimated values. Here we are testing the significance of estimated value. Constant value is significant, but coefficient of height is not significant, because this is less than 0.05, but it is not less than 0.05. So constant is significant value, but coefficient is not a significant value. Like that way we are give the conclusions. Okay, for the fitting of regression models. Next, one minute please. Next, see, this is the problem, one of the problem. The actual weight of in ounces of a 15 cans of popular soft drink are as follow. This is the value, weights of soft drinks cans. Okay, in this label we have 12 ounce weight. Based on these values, are you are you conclude the average weight is 12 ounce or not? Now we are check this value at 5% of level of significance, at 5% level of significance. Okay, coming to the problem. See, here I am declare the weight of a cans, soft drink cans weight. It is in the numerical format. Okay, now I'm enter the 12 cans weight under the column, weight column. Okay, now I test the weight. See, go to analyze and select compare means. In this compare means one sample t test. Here we are applying to the one sample t test. Okay, select one sample t test from compare means in analyze. Okay, see, in analyze select one sample t test from compare means. If you are select compare means, you have have another window. It opens another window. Pass the weights to the test values. See, here you should mention the average value. That is the standard value. In this label we have 12 ounce. In the labels we have 12 ounce. They are mentioned as a 12 ounce. So that is the standard value or average value. Simply click on OK. You can get result. This is the t-test. One sample t-test. Okay, this is the one sample t-test. In this one sample t-test, we have 15 observations. Its mean is 12.06, standard deviation 0.22, standard error 0.05. Okay, and this coming to the one sample t-test results. Coming to the in these results, t value is 1.025. We have degrees of freedom 15 and significant value point two double 322 0.322. That means our assumption, our null hypothesis is accepted. That means this is this p value in this result, p value. See, this is the p value. P is greater than 0.05. So we conclude that as we accept the null hypothesis and conclude there is no significant difference. There is no significant difference in the process. There is no significant difference in the process. Simply the process follows the standards, or simply the process follows the standards. Like that way we are defines the conclusions. Okay. Next problem. See here, this is the problem with the radial tires and belted tires. They are mentioned. They are counted the mileage. Mileage means economy, fuel economy. In 12 week, they are using 10 cars, 12 cars, and drive with the first time drive with the radial tires, and second time drive with the belted tires. They are checking is any difference, between belted tires and radial tires on economy. That is the problem. Okay, see at 5% level of significance. Now I'm opening the data. Here first we are define, this is the different way to define the data. Okay, first is tire type, second is economy. Here in this tire type, these two are the numerics. Okay, numeric value I'm taking as numeric. See, for tire type I'm define values as 1 for radial tire, 2 for belted tire. Okay, economy is the numeric value, no need of another definitions. So coming to this, see 1 for radial tire, 2 for belted tires. First of all, I'm enter the radial tires data. First of all, I am enter the radial tire data. Okay, next belted tire data. Enter the next belted tire data. See, this is the data. First I entered this data under 1 radial tire, under 1. Second I entered the data with 2. Okay, column name 2. Okay, this is the way I'm entered the data. Previous I'm entered in only different columns for correlations, but not here like that way. Okay, see, now we are calculate that two sample t-test as go to analyze, select independent sample t-test from compare means. Independent sample t-test from compare means. See, in this analyze, go to compare means. In this compare means, select independent sample t-test. Okay, if you are select this, you can get another window. In this another window, observe, carefully observe here, this is the test variable. You should enter the test variable here. Okay, select economy to the test variable. Okay, here the economy is the test variable. Okay, next, grouping variables. It tire type, this tire type is the grouping variables. Pass the grouping variables to the tire type to the grouping variables and define here. First group is 1. You should define here, you should define the group types. 1 for first group, 2 for second group. Okay, I will explain once again. In this analyze, go to compartments. In this compartments, select independent sample t-test. In the sample t-test, first select the economy. Economy is a test variable. Economy is a test variable. Pass that economy to the test variable. And tire type is the grouping variable. This is in this problem, tire type is the grouping variable. Pass that tire type to the grouping variable and define. Here you should define the values, grouping values. You should define the grouping values. 1 for first group, 2 for second group. Okay, here in this problem we are define 1 for radial tire, 2 for belted tires. Like that way we are entered define here. Click OK. Okay, this is the two sample t-test result. See here, it is the radial tire. Radial and belted tires. Okay, 12 observations. 12 observations. Radial tire average economy, belted tire average economy, standard deviations and standard errors. In this data, see, economy. Economy is our variable, testing variable. In this testing variable, generally we are consider first row only. In this two sample t-test, first row only. Here variances are equal for both the groups. Variances are equal. With that assumption, we are calculated first value. The second is not equal. Okay, generally everyone consider as a first, considers first row. In this first row, leave the statistic significant value. Check the significant value. Okay, check the significant value. This is the significant, nothing but p value. P value is equal to, p value here for this problem we have 0.835. This is greater than 0.05. So our H naught is accepted. Our H naught is accepted. That means there is no significant difference between the use of radial tires and belted tires. Okay, H naught, if H naught is accepted means, say we says that is there is both tires are gives same economy. Both type tires are gives same economy. If it is less than 0.05, if it is less than 0.05, you can say there is a significant difference. But we get like this way, say so we says that there is no significant difference. Both type of tires gives the same economy. Simply we conclude that way. Okay, next problem. Coming to the next problem. The following table gives the weights of 10 children before and after taking the protein food. Is that protein food effect on their weight gain? This is the simple some of the one of the medical problem. They are taking measures before and after the use of protein food from 10 children. Okay, they are asking is effect or not. Okay, for this type of data, we are using paridity test. For this type of data, we are using paridity test. See. See here, I'm enter defines before before weight children weight before taking protein food, children weight after taking protein food. Okay, for variable names before and after. See, I'm enter the data before under before data, after data. Okay, some value is missing here. 0 is the 0 is okay, right. For testing this type of problems, we are using paridity test. Go to analyze, select compartments. In that in this compartments, select paired sample t-test. Okay, you can get one window, separate window. Once again, I will explain. Analyze, compartments. In this compartments, paired sample t-test, paired sample t-test. Okay, you get this type window. Pass the values, compared values, pass the compared values one by one. See, first variable, children before protein food, taking protein food. Second, children after protein food. See, before and after. Just click OK. We have another type of options here. Confident limits, you can define your own confident limits. 90% or 95% or 99% you can calculate. Okay, just click on OK. See, this is the paired sample t-test. Okay, in this we have, see, children's average weight before taking protein food 7.6, after 8.8. Okay, 10 members, same members. Here we are applying the treatment on same members before and after. We are taking the before and after. Say these are the related data types, related variables. This is the related variables. Okay, see, coming to the results here, mean difference value -1.2, standard error significant value is 0.2, significant value is 0.2. That is p value is greater than 0.05. P value is greater than 0.05. That means H naught is accepted. That means you say no effect of taking protein food. The taking protein food not affects the children weight. Simply we says that taking protein food on protein no effect on children's weight. Okay, that way we are define the conclusions for paridity test. Next, this is parity test. Next, ANOVA one way, analysis of variance one way. Here there is a 3 players. They are played in 6 games. They are asking there is any significant difference between the players. There is any significant difference between the players. For this type of data, we define different way. See, we have 6 games. This is the first player A scores in 6 games. These are the player B scores in 6 games. These are the player A scores. Okay, for this player A, we define like 1 player A, consider as a 1 player A, consider as a 1 first, for first game 1 148, 1 player A first game 150, player B player A third game 157, like this way. Next, after player A completion, we take player B as 2. For 2 player B, for player B in this first game they scored as 175. Next, in second game, player B in second game 165. Next, after this enter the data, player C consider as a 3. Player C in first game 158, like that way we are define the variables. Okay, see, first of all I am define the players. Okay, players 1 for A, B, 2 for B, 3 for C. Scores, different scores, all are in numeric format. Okay, I'm taking as a numeric format. This is the data. Player A score 6 games score. Player B 6 games score. Next, player C 6 games score. Simply now I'm calculating the ANOVA one way. As go to analyze, select ANOVA from compare means. See, go to analyze. In this analyze, select compare means. In this select one way ANOVA. Okay, once again I will explain. Analyze, compare means, one way ANOVA. You will get this window. Okay, here you should define players are independent factors. Players are different factors. 3 players are 3 factors. Okay, their scores are dependent variables. Their scores are dependent variables. Okay, see, players factors, players forward to factors, scores forward to dependent list. Simply here post-heuristic test, you can select the different type of post-heuristic tests. Okay, depending on your study nature, based on study. Okay, click OK. You will get the result one way ANOVA. See, this is the one way ANOVA. In this one way ANOVA, between groups, this is the between groups. See, this is the values between groups, within the groups, total. Next, degrees of freedom. Simply we are consider this value, p value. P value is less than 0.05. Here for this problem, p value is less than 0.05. So we reject a null hypothesis. Reject a null hypothesis means there is a significant difference between the players. Simply we define as, we says that there is a significant difference between the players. Okay, right. Based on p value, we says that the problem conclusions. Okay, next problem. ANOVA 2A. Here we have uh, five types of medicines, different types of medicines. We have four different types of medicines and four patients, five different types of medicines, four patients. They're asking uh, test the effect of medicine and patient immunity. Both they're asking the both. They're asking the both here. In this previous problem, they're asking only is there any significant difference between players, but here they're asking is medicines are effective or not, patients have same immunity power or not. In both the way they are asking. So for this type of questions we are using two-way analysis. Two-way ANOVA two-way analysis. Please observe once again, observe this way. This is the data. This is the data entered carefully. First, see, simply consider this is a matrix. Consider this is as a matrix. Okay, this part matrix values, like that way I am assuming that A11, A12, A13, like that way I am assuming that values. A11 is the 12, A12 is 16, A13 is 18. Okay, A44, what is the value A44? Here A44 is the 25. Okay, like that way we are defining. See, 11, 12, 13 in this column, in this column, in SPSS we are enter like this way. 1, this is the row value, first row 1. Okay, first column, here define column, here values, here values, here this 12 address is 12 address. For this 12, this is the first row, first column. Okay, 1 1 value 12. Okay, next 16, for 16, this is the first row, second column. In this rows, first row, second column. Okay, value 16. Next, see, for 18, first row, third column. Like that way we are entered. Okay, see, data. Here variable declaration is different from other values, from other type of calculations. See, 11, it is the patients medicines, from the first patient, first medicine, this is 12. Okay, from second patient, first medicine, 16. Next, third patient, first medicine, 14. Okay, next, first patient, second medicine, 16. Second patient, second medicine, 25. See here, 25. Second patient, second medicine, value 25. See, second patient, second medicine, value 25. Next, third patient, second medicine, third patient, second medicine, 20. Okay, like this way, there enter we are enter the data. 24. Okay, this is coding. This is coding. For two-way analysis, go to analyze. Here, general linear models. We are selecting general linear models. In this general linear models, select univariate. In this univariate, dependent variable is count. Okay, dependent variable is count. White blood cells count. Okay, pass this value to the dependent variable. Patients and medicines are the fixed factors. Patients and medicines are the fixed factors. Pass these two to fixed factors. Click on model. Click on model. In this model, we define the model variables. Build terms. Select build terms. Pass the values. Patients, variables, and patients, medicines to the model. Pass the factors to the model. Okay, click on continue. Here we have interactive. See here we want to two-way model. We want to two-way model. So select two-way. Here it is the type 3 means null hypothesis. Based on null hypothesis, these values are calculated. Based on null hypothesis, these values are calculated. Click on continue. Okay, next click on OK. You will get the result. You will get the results. I will explain once again. See, analyze, go to analyze. In this analyze, select univariate from general linear model. Analyze general linear model, univariate. Okay. Analyze general linear model, univariate. In this univariate, dependent variable is count of white blood cells. Next, fixed factors are patients and medicines are the fixed factors. Okay, after this define model, in this model select built terms. In this built terms, we pass the patients and medicines to the model and select two-way analysis. Okay, here sum of squares type 3 means it is the taking as a null hypothesis. Okay, define as null hypothesis. These are the defaultly selected. Click on continue. Then click on OK. You can get the result. In this result, see, these are the significant values. Based on these significant values, we draw conclusions. Leave these corrected models, interactive models. See, patients, you should take only rows and column values. For these rows and columns, for patients, p-value is less than 0.05. For medicine also, p-value 0.05. For this problem, we are concluded that both patients and medicines are significantly effective. Both patient and medicine are significantly effective. Okay, patients are different immunity powers, and medicine has different effective on patients, effectiveness on patients. Like that way we define. Next. Next problem. Chi-square test. Here we are here I am taking smokers affected with lung cancer. This is the data. Okay, but actually its data is smoker or not. That is like this way. This is the data. Here I am define as see here I am define the variables. Smoker. Okay, in the smoker values, one for smoker, two for non-smoker. Also cancer, also for cancer variable where as I am defined as one for affected, two for not affected. Simply I am enter the data 1 2s 1 2s 1 2s. If they are giving smoker as answer 1, affected with cancer 1, if it is non-smoker affected with cancer 1. Like that way I am giving the I enter the data, this data, and with this data I'm calculated chi-square. See, simply go to analyze descriptive statistics, go to descriptive statistics, uh, frequencies, select frequencies. In these frequencies, no, sorry, go to analyze, uh, select descriptive statistics. In this descriptive statistics, select crosstabs. In this crosstabs, smokers, take it as a smokers as a row, cancer affected as column. Okay, here we have statistic. In this statistics, if you are click on statistics, we get another window. In this window we have different type of validation measures, correlate, chi-square, correlations, and other. Okay, for this data we want to test chi-square, we want to calculate chi-square. Select chi-square and click on continue. Next, click on OK. See, this is the cross tab, smokers, in our data we have 7 smokers with affected with lung cancer. Non-smokers not affected with lung cancer is 36. These are the affected persons, not affected persons. Even they are non-smokers, they 11 persons are affected with lung cancer. Okay, this is the cross validation table. Okay, in this table here, this is this is the chi-square test values, chi-square table. In this chi-square table we are consider this Pearson chi-square value, Pearson chi-square value. Okay, this is less than, this is the sorry, sorry, This is significant value. This is p value. P value is less than 0.05. This is the p value. It's less than 0.05. Okay, so we conclude that the test is significant. Test is significant. There is, okay, test is significant. And also conclude smokers is affected with lung cancer. Okay, next problem. In this problem, professors are two professors, two professors test the patients, and for same treatment, and gives presents the results here. These are the results. Okay, based on these results, we calculate both are same or not. Both are same or not. Here, we are taking as a median, not a mean. So that's we are using manually run some test. Okay, see for this problem. Thanks some. This is a value. Professors. Here we have two professors. So that's why I'm taking as a numeric value Professor A, Professor B. Professor A as 1, Professor B as 2, and score values. See, for Professor A scores, these are the Professor A scores. These are the Professor B scores. To test manually, you test manually test. Analyze, go to analyze. In this analyze, non-parametric test. Under non-parametric tests, in this analyze under non-parametric test, you should select the two independent samples. Professors are both are independent, so two independent sample tests. See, analyze non-parametric legacy dialogues. In this legacy dialogues, we are selecting independent samples. Okay, these are the we can get this window. Okay, in this window, grouping variable is professors. Select grouping variables and define the groups. One is Professor A, two is Professor B. Grouping values. Okay, next test variable. Pass the test variable to the score to the test variables. Here manually you test, or Kolmogorov are different way. Both all are the similar, but some differences are there. Here we are applying the manually you test. Okay, this is the result. Manually you test. See, in this result, we have eight members. Each professor gives the results for 8 members. Okay, main values 6, main ranks is 6 to 11. Okay, based on this test, a significant value, asymptotically significant value. This is the p value for our test. This is the p value for our test. This is less than 0.05. Okay, less than 0.05. This means there is a significant difference. There is a significant difference on the treatment given by both professors. Okay, that way we are conclude that. Next. some medicines are one type of drug is used for autism in children. Okay, 8 children. This is the values. They are want to test the effectiveness of the drug. Okay, before and after the use of the drug. For this problem, I am enter the data like this way. See here, first before treatment to after treatment, before treatment, after treatment, before treatment values to after treatment values based on autism. Okay, right. Now I'm using Wilcoxon sign rank test as like this way. Select, go to analyze, go to analyze. In this analyze, go to non-parametric test. In this non-parametric test, select related samples. Here we are select the related samples. Patients are same, but values before treatment and after treatment. So we are take here two related samples. Here we have only two, so we are taking two related samples. Okay. If you are select that two related samples, you get this type of window. In this type of window, pass treatment values, before treatment value first variable, after treatment variable second variable. See, select this different type of tests here. Okay, Wilcoxon test, I am selecting as Wilcoxon test. Click on OK. This is the result. See, mean ranks, standard values, ranks, standard values. From this calculations, this is the significant value, test significant value. This is the p value. For this test, p value we have 0.049, that is less than 0.05. So we says that there is a significant difference before and after treatment on autism. Okay, you can conclude like that way. Next. Example of crystal Walser test. Here, depressed patients. There, this is the problem on depressed patients. For reducing the depression, they are giving like one type of treatment. Um, okay, here 20 exercise. Exercise is a treatment. Is any exercise is affected on depression or not? Here they are want to test the exercises affects the depression or not. Okay, like that way they are giving treatments. See, in this they are grouping like no exercise persons, jogging for 20 minutes per day, jogging for 60 minutes per day. These they are splitting the patients like this way. Okay, no exercise, at least 20 minutes, at least 60 minutes of jogging. These type of three groups. They want to test this exercise is effect on making less severe depression or not. Okay, for this type of data we are using crystal Walser test. Okay, see. I'm enter the data. First type of exercise. See here exercise one for one for no exercise, two for jogging at least 20 minutes, three for 60 minutes. Okay, and score values. These are the score values. Second is the score values. See jogging. These are the up to 8. Up to 8. These are the no exercise persons. From 9 to 16. These are the up to 20 minutes of exercise. Next 60 minutes exercise persons. For testing crucial value test, select analyze, go to non-parametric. In this non-parametric, go to legacy. Here these are the independent. So k independent samples, we are select the k independent samples. These are independent. Some patients are taking rest, some patients are taking 20 minutes of jogging, worked on 20 worked for 20 minutes, and some are worked for 60 minutes. These are independent, so we are selected as independent. Okay, here grouping variable. Here grouping variable is exercise. In this grouping variable, define, we have three types. One is no exercise, two is 20 minutes, three is 60 minutes. So minimum value is 1, maximum value is 3. Okay, here minimum value 1, I am entered 1, and maximum value 3. Click on continue. Okay, next test variable. Here test variable is scores, pass to the test variable. Scores pass to the test variables. Select crucial values to test and click on OK. These are the result. These are the results. See, we have 8 members for each group. Okay, their mean rank. These are the mean ranks. Okay, under this table, under this test, we are consider p value. This is the p value. Okay, in the for this test, p value is 0.026. This is less than 0.05. So we conclude that jogging, physical exercise is effective. Physical exercise is effective. Physical exercise is effective. Simply we reject the H naught and conclude that physical exercise is effective. Okay, physical exercise is effective. Next problem. See, in this problem, drug reaction time. They are consider drug reaction time different, six types of drugs reaction time on three conditions. In three conditions. Okay, in three conditions. ABCDEF are the different types of drugs. Their reaction time, they are measuring the reaction time in three different conditions, 1 to 3 conditions. Okay, this is the data. For this type of data, we are use a fragment test. Okay, they are asking is same or not, is same reaction time is same or not at any different level of tests. So for this type of data, we are using fragment test. Okay, see, these are the objects, means drugs, different drugs. Here I am taking drugs as a objects. Condition 1, condition 2, condition 3. Simply I am define like this way and enter the data under objects. Under objects 1 to 6 different drugs. and condition 1, the reaction time, condition 1 reaction times. See, condition 1 reaction times 356, 590 vertically I am entered. Similarly, remaining 2 columns. For this Friedman test, we are calculated as, go to analyze, select non-parametric test. In this non-parametric test, go to legacy. Here, all are the related samples. All are the related samples. So take it as a k related samples. K related samples. In this related samples, select conditions. First condition, second condition, and third condition. Friedman test. Select the Friedman test and click OK. Okay, this is the results. See, asymptotic significant value. Asymptotic significant value is the p value for this test. This is the p value. P value is for this test. P value is 0.311, which is greater than 0.05. Okay, so we conclude that the reaction times are similar at any conditions. Thus, reaction times are similar at any conditions. Like this way, we are calculating different types of testings, okay, and gives the conclusions. See, these are the parametric and non-parametric methods. Okay, for compare means between two independent samples, we are using t-test, simple t-test in parametric, Wilcoxon rank sum test in non-parametric. Comparing two quantitative measures from taken the same. Here in parametric, these are the related samples. For related samples, we are using periodicity test in parametric. Under non-parametric, we are using Wilcoxon signed rank test. Okay. Comparing between the more than 3 groups, comparing means between more than 3 groups between more than 3 groups, in that situation we are using ANOVA in parametric and Crucial Waltz in non-parametric. Like that way, these estimated values we are using relation between the estimated association we are using parametric test, coefficient, Pearson correlation coefficient under parametric tests, Spearman's rank correlation coefficient under non-parametric tests. Okay, any doubts? Please respond, anyone.
Dear participants, if you have query, you can ask to the resource person. Otherwise, you can post it in the chat box. Huh? Sir, participants, do you have any doubts or queries?
Please give feedback on this website or in this link. I'm
Okay,
sharing
sir.
one link
Uh,
in
Sir,
chat
that
box.
link posted in the chat box, sir.
Yes, sir. I link shared in chat box.
Okay, sir.
Thank you for giving this opportunity once again, Madam Principal, Madam, and Srinivas Garu, for institution also.
Thank you, sir.
Thank you, sir.
Thank you very much, sir.
Thank you, sir.
Really, it is very useful and informative, sir.
Thank you, sir. Okay, sir.
You have explained in easy manner with the example of clinical pharmacy related data.
Okay, sir.
It is very useful for all faculty members in faculty pharmacy side.
Yes, sir.
And also your demonstration made us more aware about the SPSP software, sir. Thank you very much, sir, for accepting our invitation.
Okay, sir. Thank you, sir.
Thank you, sir. Sir, just wait, sir. Participants. Sir, this software is available as a free version, sir. Only purchase.
It is a free version for students, sir. Older
Only
version available in website, not a latest versions.
okay, sir.
Or
It's
for
not advanced version.
this is not advanced version, older versions.
Okay, sir. Sir, that free version validity is how many days, sir? It's 1 month or 1 week or that. Some of the software is
Some
given
15 days or
free, 15 days.
15 days. Sometimes we have pirated versions are there, sir.
Yeah, sir. Okay, sir.
That will
Sir,
help you work for that.
may I know the cost of the software, sir?
This is for 8 systems, 2 lakhs, sir.
8 systems means, okay, sir. Okay. 2
2
lakhs.
2
So
lakhs.
it's a lifetime validity, sir?
Lifetime validity. This version is lifetime validity.
Okay, sir. Okay. At a time, 8 members can use this software, sir?
In 80 different systems.
Okay, sir. Just a minute. Participants, if you have any doubts, please post it in the chat box. Otherwise, you can ask directly to the resource person.
In our institution, in our company,
Yes, sir.
we are working with industrial data.
Especially.
Data, like banks and other type of data. Okay. Also, we
Okay.
are giving training for students in data science tools like advanced Excel, Tableau, Power BI, SQL, Python, machine learning, like that. In SPSS and SAS also, we are giving training for the students. Because we are observed in this society, there is a gap between education institutions and industries. We try to fulfill that type of gap. Like we are giving training. Also, we are also giving training for the students in our company.
It's
Both
company in Vijayawada only, sir.
Vijayawada, in nearer to VR Siddhartha College, sir.
Okay, sir. May I know what is the fee structure for training program, sir?
Okay, sir. It is depending on the courses, sir. It's depending
Okay,
on
courses
course.
means for only SPSS.
Only
Like
only SPSS. Here we are not teaching SPSS. We are teaching only giving training on Tableau, Power BI, Excel, SQL, next Python, SAS. Okay.
Okay, sir. Okay.
Many of the students like only need this type of courses. SPSS is
Okay,
very
sir.
simple. Okay.
Okay, sir. Thank you, sir.
Yes.
Okay. Now we will go for vote of thanks.
Okay, sir.
End of the session. A very good evening to respected Principal Madam Dr. K. Padmalata, convener of this faculty development program, and Dr. K. Srinivas Garu, today's resource person, all faculty members, research scholars from various colleges, my dear colleagues who participated in this faculty development program. This FIDES faculty development program conducted in virtual mode for the convenience of resource persons and participants across the India. We are honored and delighted to host this 5 days faculty development program, and total 436 faculty and research scholars were registered in this 5 days virtual faculty development program. We have proud to have to all this faculty development program. The theme of this 5 days faculty development program is research methodology and data analysis. This 5 days FDP made us more confident and knowledgeable on topic selection, proposal writing, research design, hypothesis, and data analysis using parametric and non-parametric methods, and different softwares like Minitab and SPSS. On behalf of Principal Madam and IQAC and faculties from VIPW, I would like to thank all the resource persons, Dr. Anabalagan sir, Dr. T.E.G. Gopala Krishnamurti garu, Dr. A. Suhasini garu, Dr. V. Srinivas garu, Dr. K. Srinivas garu for accepting our invitation and improved our research and data analysis skills. Hope this faculty development program was great and successful, and all of you enjoyed this program. I would like to thank Dr. Anabalagan sir for accepting our invitation and deliver a talk on selection of research topic and proposal writing. Your lecture made us more confident and knowledgeable to select the research topic and write the proposal for funding agents, sir. Thank you very much, sir. I thanks to Dr. T.E.Z. Gopala Krishnamurti garu for deliver the lecture on research design and data analysis using Minitab software, sir. Your DOE demonstration was enhanced our learning process, sir. Thank you, sir. Thank you very much. I thanks to Dr. Suhasini garu for wonderful talk on hypothesis and statistical significance in scientific research. Thank you, madam, for your presentation and practicing demonstration. I thanks to Dr. Srinivasa Garu for accepting our invitation and made us more knowledgeable on analysis and interpretation of data using parametric and non-parametric methods. Thank you, sir.
Thank you, sir.
Thank you. I thanks to Dr. K. Srinivasa Garu for accepting our invitation and deliver a talk on quantitative data analysis using SPSS software. Thank you, sir. Your session has increased our expertise of research and data analysis skills using SPSS software, sir. Your explanation is very useful for all us, sir. Thank you, sir.
Thank you, sir.
I would like to thank all the faculty and research scholars who participated in this faculty development program. Your participation added more value to this faculty development program. Thank you all for your active participation. I would like to thank Dr. K. Padmalata Madam and management Vijaya Institute of Pharmaceutical Sciences for Women for their constant support and given opportunity to conduct this 5 days faculty development program. But last but not least, I thanks to all my dear colleagues for your constant support and guidance to conduct this 5 days faculty development programs. Thank you very much. Thank you all for giving me this opportunity to conduct this faculty development program. Thank you all. Participants, I will share the feedback link in the group. Then you will get the certificate automatically to your mail ID. Thank you all for your active participation. Thank you very much.
Thank you, sir.
Thank you, sir.